listening, we're going to open the door in about 3 minutes or so.
I'd like to make a right turn and climb to 4-1 or 4-3 if that's possible.
Good.
Point 1 on bore side.
All right, thank you.
Observing.
Some of the trepidation initially was, oh my gosh, are we going to be able to stay up all evening? My adrenaline is so flowing right now that has not been an issue. I'm just as excited here, 2:30 in the morning, as I was at 7:30 in the evening. I certainly hope that I will be able to take that excitement, that awe of what's going on in this 747 this evening, and impart that to the students, whether they be young students, whether they be adults, and get them thinking about what could I learn from the astronomy that's being done aboard this program.
Tonight we have everything from learning about the forecast instrument, how SOFIA works, what they're imaging, what they're trying to learn about objects using infrared.
I've learned about how hard it is to plan a flight path and all of the different targets they have along that flight path. My students have such a limited knowledge of the electromagnetic spectrum. I want to show them that there's so much more that can be learned beyond the visible light spectrum.
We're looking at massive star-forming regions in the direction of the constellation Sagittarius, looking toward the center of the Milky Way galaxy.
The protostars, how they develop and the temperatures they develop and what's happening within those nebula that they're developing within, being able to see how they can see through the dust clouds into those little nurseries of the protostars has been fascinating.
So one of the advantages of using a GRISM is that you can just plunk the element into a filter wheel, right? So you can pop it out, put in an imaging filter, and it functions essentially the same way. If you'd like your students to be involved, they do have ways that you can actually get involved with the general investigators to have them work with you directly with their data.
I can see so many different ways to take this back into the classroom.
Part of our job as teachers is to take science from scientists and translate it so the general public can understand it. My role, I guess, in addition to regular classroom visits that I would be doing, is developing planetarium lessons.
So using SOFIA, you can see the central regions even
There's
if
specific content connections that I can make with what we're doing on board here on SOFIA, such as learning about stellar life cycles with new stars forming in regions within space, but also just the careers that are on board, the different educational backgrounds of all the people on board, the different jobs they can have. They don't all have to be astronomers to have a part in this program and an exciting career in which they're learning all the time.
One of the biggest challenges for students with visual impairments and blindness is involvement into the STEM fields. And to get them excited, I think, is probably the most important thing that we can bring back.
Science always needs intelligent people that have a different perspective or are going to think about a problem differently, and just because they can't see doesn't mean they can't think about these problems and develop something new or revolutionary.
Translating astronomy, just visual astronomy, is challenging enough, and translating infrared astronomy adds an extra layer of difficulty. One of the things that we've done just for this trip is we've actually embossed the SOFIA aircraft complete with the outline of the telescope, and it's allowed our students the opportunity to kind of feel what the plane is like and where the telescope is at in relationship to the overall plane.
Being a space history museum, we have a lot of astronomy opportunities. SOFIA, with the platform that operates on, offers an extremely unique opportunity to take those persons who might come to one of our star parties, might want to come to one of our solar events, to a far, far different level. We can take those participants in our programs rather than just, hey, look through this lens and see what you see. Here's what we were able to accomplish and see once we were at 43,000 feet. And how infrared astronomy works.
And I remember being taught this way. Okay, open your book to chapter whatever. First kid reads the first paragraph, second kid reads the second paragraph, third kid, if they can, read the third paragraph.
Just right
and
click.
then it wasn't particularly interesting.
And how to connect this with
If you can actually do something. Here's some data that was gathered. here's how you reduce it, here's how you use it, this is what it's important for, and look at what you get at the end. I think kids really enjoy real things, and that's what this is. That's my favorite part.
Those first 2 dots indicate that everything after it is a capital letter. Tonight we had Nichelle Nichols, who played Lieutenant Uhura on the original Star Trek series. To have her on board to encourage education, to encourage involvement, to encourage exploration, it just helps everyone out. It's wonderful.
So this is all emission in the infrared portion of the spectrum.
I was a child when Star Trek came on. That sort of helped spur my interest in science, spur my interest in space.
We share in common a passion for getting underrepresented groups in STEM. That's one of my biggest things, is getting women and minorities into STEM fields. And so she's a wonderful ambassador for that, and I'm really proud to have flown with her tonight.
She was, still is, just an amazing, lifelong learner.
I just hope I'm as enthusiastic and that lifelong learner at 82.